Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel, Assistant Professor from LJ Institute of Engineering and Technology. Last session we are already discussed about the infinite sequence. Today's session we are going to discuss about the infinite series. You all are aware about the finite series. Nowadays we are going to expand it to in an infinite series. Let's see firstly infinite series. If we are going to add the terms of infinite sequence, that can be expressed as u1 plus u2 plus u3 up to un and so on. It is called the infinite series. Now let's see the notation of the series. Basically series has two types, finite series and infinite series. If the series is infinite, then it is denoted by summation where n is running from 1 to infinite un, or we can say that simply sigma un. If series is finite, then it is called the finite series and it is denoted as summation where I which is running from 1 to n ui. Now let's see the next one is partial sum. If sigma n equal to 1 to infinite un is a series, then partial sum is denoted by Sn. In general form, Sn equal to u1 plus u2 plus u3 up to un. Means partial sum is the summation of the first n term of the series, which is denoted by summation I equal to 1 to n ui. If we have a S1, then we consider only first term of this series, that is u1. Suppose S2, then consider the addition of the two terms of this series, means u1 plus ut. Similarly S3, then u1 plus u2 plus u3. Similarly suppose S4, then u1 plus u2 plus u3 plus u4. Now let's see the next topic, which is convergence and divergence of this series. If Sn tends to finite or a unique limit as n tends to infinite, then we can say that given series sigma un is convergent. For example, limit n tends to infinite, Sn equal to finite. Similarly, for the divergence series, if Sn tends to plus or minus infinite or limit does not exist or more than one limit, then we can say that our given series is sigma un is divergent. For example, limit n tends to infinite, Sn equal to plus or minus infinite, or limit does not exist or more than one limit. If we have more than one limit of the series, then we can say that it is oscillatory series. Oscillatory series, that is a particular form of the divergence. Now let's see the few properties of the series. You all are aware about the basic properties of sequence. Similarly, few properties of the series. If sigma un and sigma vn are two convergent of this series, then sigma cun, sigma un plus vn and sigma un minus vn are also convergent, where c is a any constant term. Then sigma cun, then c which is constant and comes out this series, and sigma un plus vn, then individual summation which is given, then we can write sigma un plus sigma vn. Similarly, in subtraction form, we write sigma un minus sigma vn. Now next property is removal or addition finite number of the terms does not affect the convergence of the series. Now let's see the examples of the convergence and divergence for the telescopic series. Here our un is 1 upon n into n plus 1. Firstly, our series is sigma n equal to 1 to infinite 1 upon n into n plus 1 is convergent and find its sum. Here that is a telescopic series. Then whatever the term which is in form of n, that is indicated by un, that un equal to 1 upon n into n plus 1. Now with the help of part subtraction method as well as term adjustment method, here I use term adjustment method, then in numerator portion add n or subtraction of the n and simplified it, then we get 1 upon n minus 1 upon n plus 1. Now Sn equal to u1 plus u2 plus u3 up to un. Sn is a nothing but the summation of the n term of the series. Now in this un, substituting the n equal to 1, then we get 1 minus 1 half, n equal to 2, then we get 1 half minus 1 by 3, n equal to 3, then we get 1 by 3 minus 1 by 4. This all the values substitutes in Sn. Then in this series, second and third term will be cancelled out, third and fourth term will be cancelled out, and so on. In short, except first and last term, remaining all the intermediate terms are cancelled out, and our Sn becomes 1 minus 1 upon n plus 1. Now we have to check out the given series is convergent or not. Then we applying the limit n tends to infinite to the Sn, then it becomes limit n tends to infinite 1 minus 1 upon n plus 1. Now 1 upon infinite it becomes 0, then 1 minus 0 is equal to 1, means our answer is finite. Then we can say that our series is convergent and its sum is 1. Now let's see one more example. Summation n equal to 1 to infinite n square is divergent. Here un is n square. Now substituting the n equal to 1, 2, 3, 4, 5 and so on, then our Sn becomes 1 square plus 2 square plus 3 square plus 4 square up to n square. You all are aware about the sigma n square is a nothing but the n into n plus 1 into 2n plus 1 by 6. Now we have to check out the our series is convergent or not. Then applying the limit n tends to infinite to the Sn, then it becomes limit n tends to infinite n into n plus 1 into 2n plus 1 divided by 6. Now applying the n as a infinite, then we get infinite, means here limit does not exist. Then we can say that given series is divergent. Now let's see what more examples of the convergence or divergence. If it is convergent, then find its sum. Here un equal to 1 upon n into n plus 1 into n plus 2. Here denominator portion has a total 3 product form. Then we consider only 2 as a product form and one term which is common out. Then here I n plus 1 which is common out, and remaining term 1 upon n into n plus 2. In this term, with the help of term adjustment or a partial fraction method, we can simplify it and we get 1 half n plus 1 inside the bracket 1 upon n minus 1 upon n plus 2. Now 1 upon 2 as it is and n plus 1 which is comes inside the brackets, then we get 1 upon n into n plus 1 minus 1 upon n plus 1 into n plus 2. Now here Sn equal to u1 plus u2 plus u3 up to un. Now substituting the n equal to 1 in un, n equal to 2, n equal to 3 and so on, then we get this type of series. In this series, second and third term will be cancelled out, fourth and fifth term will be cancelled out, sixth and seventh term will be cancelled out and so on. In short, except first and last term, intermediate all the terms will be cancelled. Then our Sn becomes 1 half inside the bracket 1 upon 1 into 2 minus 1 upon n plus 1 into n plus 2. Now we have to check out the given series is convergent or not. Then applying the limit n tends to infinite to the Sn, then we get it is 1 by 4, means it is finite answer. If our answer is finite, then we can say that given series is convergent and its sum is 1 by 4. Now let's see the one more examples of the convergence or divergence, that is summation n equal to 1 to infinite tan inverse 1 upon n square plus n plus 1. In denominator portion n square plus n means first two term n which is common, then we get 1 upon n into n plus 1 plus 1. Now in this term multiply and divide with 1 upon n into n plus 1 in numerator and denominator. Then it becomes tan inverse 1 upon n into n plus 1, 1 plus 1 upon n into n plus 1. Now in numerator portion we have one term, we have 1 upon n into n plus 1. Now simplified this term with the help of term adjustment, means addition and subtraction of the n in numerator, then we get n plus 1 minus n. Simplified it, then we get in numerator portion 1 upon n minus 1 upon n plus 1. Then here we get tan inverse inside the bracket 1 upon n minus 1 upon n plus 1, in denominator portion 1 plus 1 upon n into 1 upon n plus 1. Now with the help of basic formula of the trigonometric, which is tan inverse x minus y upon 1 plus xy equal to tan inverse x minus tan inverse y for mod xy less than 1, which is already learned in earlier standard. With the help of that formula, we get tan inverse 1 upon n minus tan inverse 1 upon n plus 1. Now here our Sn equal to u1 plus u2 plus u3 up to un. Now substituting the n equal to 1, n equal to 2, n equal to 3 and so on, then we get this type of series. In this series, except first and last term, all the intermediate terms will be cancelled out. Then our Sn becomes tan inverse 1 minus tan inverse 1 upon n plus 1. Now we have to check out the given series is convergent or not. Then we applying the limit n tends to infinite to the Sn. Then limit n tends to infinite, tan inverse 1 minus tan inverse 1 upon n plus 1. Here n tends to infinite, then 1 upon infinite it becomes 0, then tan inverse 0, that is 0. And you all are aware about the value of tan inverse 1, that is pi by 4. Then it becomes pi by 4 minus 0 is equal to pi by 4. Means our answer is finite. Then given series is convergent and its sum is a pi by 4. Now let's see our next upcoming topic is a geometric series. Here a plus ar square plus ar cube up to ar raised to n and so on equal to summation which is running from n equal to 1 to infinite ar raised to n minus 1 where a not equal to 0. Here basically two conditions, if r equal to 1 and r not equal to 1. Let's see the first condition, if r equal to 1, then what our geometric series which is Sn equal to a plus ar square and so on. In this series substitute the r equal to 1, then we get a plus a plus a plus a up to and so on plus a, means n times a, then it becomes na. Now applying the limit n tends to infinite to the Sn and it is becomes in plus or minus infinite, means our limit does not exist. Therefore we can say that given series is divergent for r equal to 1. Let's see that if r not equal to 1, then our Sn equal to a plus ar square plus ar cube up to and so on plus ar raised to n minus 1. Now multiplying this equation with r, then it becomes r Sn equal to ar plus ar square plus ar cube up to plus ar raised to n minus 1 plus ar raised to n. Now difference between these two equations and simplified it and to become the subject as a Sn, then Sn equal to a inside the bracket 1 minus r raised to n upon 1 minus r. Now we have to check the convergent or divergent, then applying the limit n tends to infinite to the Sn, the limit n tends to infinite a inside the bracket 1 minus r raised to n upon 1 minus r. Now with the help of basic properties of this series, just individual the sequence, then a upon 1 minus r minus a upon 1 minus r limit n tends to infinite to the r raised to n. Here if our r is r which is lies between minus 1 to 1, then r raised to n becomes 0 if as a n tends to infinite. Then limit n tends to infinite, r raised to n becomes 0 as a n tends to infinite. Then it becomes a upon 1 minus r, means when the mode r less than 1 or r lies between minus 1 to 1, then our answer is finite. Then we can say that geometric series is convergent and its sum is a upon 1 minus r. Now r less than or equal to minus 1 or r greater than 1, the limit n tends to infinite, r raised to n does not exist, means for this range given series is divergent. Now let's see the basic summary of the geometric series a plus ar square plus ar cube and so on, where a not equal to 0 is convergent if mod r less than 1, means value of r which is lies between minus 1 to 1, then and then it is convergent and its sum is a upon 1 minus r. If it is convergent, then and then we get only its sum. If it is divergent, for mod r greater than or equal to 1. Now let's see the one example of the geometric series. If the series summation n equal to 1 to infinite 4 raised to n into 3 raised to 1 minus n is convergent. Now rewriting this equation, then summation n equal to 1 to infinite 4 raised to n divided by 3 raised to n minus 1. In numerator portion 4 which is common, then it becomes 4 by 3 raised to n minus 1. Now in this equation, substitute the values of n equal to 1, 2, 3, 4 and so on. Then it becomes our geometric series. For outside the bracket and inside the bracket we get 1 plus 4 by 3 plus 4 by 3 whole square plus 4 by 3 whole cube and so on, which is geometric series. Now we check that it is convergent or divergent. Then ratio here r equal to 4 by 3 which is greater than 1. If mode r less than 1, then and then it is convergent, otherwise it is divergent. Here ratio which is greater than 1, then it becomes divergent. Now let's see the one more examples of the geometric series. 1 plus 2 by 3 plus 4 by 9 plus 8 by 27 and so on is convergent, and find its sum. Now rewriting this series, then 1 plus 2 by 3 plus 2 by 3 whole square plus 2 by 3 whole cube and so on. And another way, summation n equal to 1 to infinite 2 by 3 raised to n minus 1, which is geometric series, and ratio r equal to 2 by 3 and value of a equal to 1. Here mode r equal to 2 by 3 which is less than 1, then we can say that it is convergent. If it is convergent, then and then we find its sum, then Sn equal to a upon 1 minus r. Now substituting the values of a and r and simplified it, then we get 3. Now let's see check out the one more examples. The figure shows that the first 7 of a sequence of the square, the outermost square has an area 4 meters square, and each of the other square is obtained by midpoint of the squares. Find the sum of areas of the squares in the infinite sequence. Here let's see the figure. There are the 7 square of the sequence. Each square is obtained by joining the midpoint of the square. Before it, area of each square is half of the area of the previous square. Now let's see the area of the second square equal to half of the area of the outermost square. Means outermost square has a area 4 meters square, then second square has area 1/2 into 4, then we get 2. Now similarly, area of third square equal to half of the area of second square, then we get 1/2 into 2 equal to 1. Similarly, area of the fourth square equal to 1/2 area of the third square, then we get 1/2 and so on. Now sum of the areas of the all these squares in the infinite sequence, then it becomes s equal to 4 plus 2 plus 1 plus 1/2 plus 1/4 and so on. In this series, 4 which is common out, then it becomes geometric series, which is 4 inside the bracket 4 plus 1/2 plus 1/2 square plus 1/2 square 1/2 cube plus 1/2 raised to 4 and so on, which is our geometric series. And a equal to 4 and r equal to 1/2 means its sum is Sn equal to a upon 1 minus r equal to 4 upon 1 minus 1/2 equal to 8. Here value of r equal to 1/2, which is lies between -1 to 1, then it is convergent. If it is convergent, then and then we find its sum. Now let's see one more examples of the series. Discuss the convergence of the geometric series. Summation n equal to 1 to infinite 2 raised to n plus 5 upon 3 raised to n. We give the two series sigma un and sigma vn. Then with the help of properties, we give the individual of that series. Then it's become summation n equal to 1 to infinite 2 by 3 raised to n plus 5 common out into 1 by 3 raised to n. Now substituting the n equal to 1, 2, 3, 4 and so on in this both the series, then it becomes 2 by 3 plus 2 by 3 square plus 2 by 3 cube up to and so on, plus 5 which is common, and remaining term which is 1 by 3 plus 1 by 3 square plus 1 by 3 whole cube plus 1 by 3 raised to 4 and so on. Here first series has a r1 that is 2 by 3 and a1 that is also 2 by 3. Second series has a r2 1 by 3 and a2 which is also 1 by 3. Now both the series has a value of r which is lies between -1 to 1, means mode r1 also less than 1 and mode r2 also less than 1, means both the series are convergent. If it is convergent, then and then we find its sum. Then sum of first series, that is s1 equal to a1 upon 1 minus r1, substituting the values of a1 and r1, then it becomes 2. Similarly, sum of second series, which is s2, that is a2 upon 1 minus r2. Now simplified it whenever we put the value of a2 and r2, and it becomes 1 half. Now we find the total sum, then which is s. So s equal to s1 plus s2, then s1 which is 2 and s2 which is 1 half, and total common term which is 5, then it becomes 2 plus 5 into 1 half, that is 9 by 2. Now this is all about the topics which is geometric series and telescopic series. I hope you guys learn something from these videos. If you like this video, then thumbs up. If you like that this video will help some of your friends, then do this share with them. If you want to watch more videos like this, then you can subscribe my channel. Thank you so much for listening me. If you have any doubts, then feel free contact me.